In this video, I will solve an example for circular permutation. Let's see what is the question. Question says the principal of a high school, 2 vice principals, and 5 teachers sit at a round table. In how many ways they can be seated? Part A, if the principal must sit between the 2 vice principals, meaning that these 3 are together and principal is seated in the middle of those. And part B says in how many ways this can be done if 2 vice principals are not in opposite seats. Okay, so to start with, what you need to know is that the number of circular permutations, meaning that you have n different objects and you want to put them in a circular way, is equal to n minus 1 factorial. So we will use that fact in this question. So let's go do part A. So in how many ways we can ask them to sit such that principal and 2 vice principals are together and principal sits in the middle of these 2. To solve questions like this, what we do is that we think of these 3 as one person. So we have then one person formed from principal, 2 vice principals, and 5 teachers. In total, we have 6 different people, and we want them to be seated at a round table. So the number of ways would be 6 minus 1 factorial. This is step 1. In step 1, we are taking president and 2 vice presidents as one person. Again, there are 3 of them, put them, make 1 person. There are 5 teachers together there are 6 people, and then the ways we can form a circle using this 6 people is 6 minus 1 factorial. But we are not done. We have to decide now what is the arrangement for these 3 that we considered as one person. So the second one would be, what is arrangement for president, principal, and 2 vice principals? Well, what is the condition? It says that the principal should be in the middle. So there is no choice for the middle one. You ask him to sit in the middle. In the right, you have 2 options, either vice principal 1 or a vice principal 2. In the left, because one of the vice principals already seated, so in the left there's only one option. This means that we have 2 factorial options to arrange these 3 when they're together. Sorry. Then by fundamental counting principle, we have to multiply these 2, and what we get is 5 factorial times 2. That's part A. How about part B? Part B says that 2 vice principals are not in opposite seats. If they're in opposite seat, we have a very good strategy to count in how many ways we can do that, which I'm going to explain in a minute. But this says are not. In situation like this, we use the complement technique, meaning that we try to count what is the complement of the situation. In this case, it is in how many ways they can be seated in opposite position. And then subtract this from the total number of ways you can do the job without any condition. In this case, so we are using complement technique. And first we have to know what is the total number without any condition. So without any condition, we have 8 people and we want them to be seated at a round table. So the number of total would be 8 minus 1 factorial. That's the total. But in how many ways these can be seated such that two vice principals are seated in opposite positions? Well, to solve this one, let's for a moment think that we have only one principal. We ask the other principal, vice principal, to be outside. And then we have 7 people, yes? We ask them to sit at the table. Well, the formula says we have 7 minus 1 factorial. Well, we are not done. We have to now add the second vice principal to the circle. But let's see how many options we have. The circle is formed, and we have one of the vice principals there. The opposite of his seat is the seat that the second vice principal should come and sit in. Well, we ask him come in and open a space in the opposite side of the table for that vice principal and ask him to sit there. And we have only one option. There's no other option. And that means that I have to multiply this by 1. Well, I now know how many total and how many ways two vice principals are together. Oh, sorry, not together, opposite. And then we subtract. So 8 minus 1 factorial is 7 factorial minus 7 minus 1 is 6 factorial. We can do a little bit more simplification for this. Let me do that one. 7 factorial, I can write it as 7 times 6 factorial minus 6 factorial. Now I have 2 6 factorial. I can factor out 6 factorial. And the remaining would be 7 from the first one. There is nothing in the second one, which means it's 1. So 7 minus 1 times 6 factorial, which gives me 6 times 6 factorial. And again, quick wrap up is that number of circular permutation for n different objects is n minus 1 factorial. And the conditions sitting opposite, I explained how to get that. Not opposite, we do the complementary. And for the other one, which a group of these people should be together, we have to form a new group, one person out of those ones, and then try to find inner permutations of that group.